Okie dokie, in this video we're going to knock out WebAssign 1.3. Number 1, factor out the greatest common factor. So the question is, what factor can we pull out of 3t to the fourth and 15t cubed? What do they have in common, in other words? So number-wise, we can pull out a 3 from 3 and 15 because 3 goes into 3 and 15. What can we pull out of t to the fourth and t cubed? Well, the highest exponent we can pull out, highest power we can pull out is t cubed. So 3t cubed is our greatest common factor. When we divide 3t to the fourth by 3t cubed, that leaves us with a t. When we divide 15t cubed by 3t cubed, that leaves us with minus 5. And that's it. So it's factoring out the greatest common factor. It's the biggest thing they have in common, basically, and then writing whatever's left. Number 2, greatest common factor again. So now we have 3 terms to consider. Let's start numbers. 8, 4, and 12. We can factor out a 4. And then, let's not do that. So, and then x-wise, we have x to the fifth, x cubed, and x cubed. We can factor out the biggest, x cubed. Now we have y squared, and y cubed. We can factor out a y. When we take the first term and basically divide by 4x cubed y, 8 over 4 is 2. X to the fifth, if we take away 3 of those x's, we now have 2 x's left. Y, we take away a y, there's no more y. Next term, 4 divided by 4 is 1. X cubed divided by x cubed is 1. Y squared over y is y. So if we have y squared divided by y, it's just leaving us with a y. Third term, 12 divided by 4 is 3. X cubed divided by x cubed is 1. Y cubed over y is y squared. And that's it. Number 3. Once again, factor out the greatest common factor. Very interesting here, but I think they're asking, like, when you look at this big term and when you look at this big term, what do those 2 terms have in common? What they have in common is that 3x plus 7. So we're going to take that away from this and from this. Now, what does it leave us with? Well, if we take it away from the first chunk, it's going to leave us with 2x. If we take it away from the second chunk, we have a 5. So we just have 2x minus 5. Number 4, greatest common factor again, but now we're dealing with a little bit more to it. So this is very interesting. So one thing I'm going to suggest is, that's kind of fun. I didn't know they did all this. Let's rewrite one of these sides, probably the second side. So I'm going to rewrite this whole thing. 18uv squared 4u minus v. And what I'm going to do is particularly rewrite that right there. I'm going to factor out a negative, so it becomes minus v plus 4u, because that's the same thing as 4u minus v. I'm doing that intentionally so it matches this 4u minus v. Okay, so I'm basically going to replace this right here with this. So how does that look? Well, it just makes this plus become a minus, basically, because it's got that negative. And then it'll just change this factor to 4u minus v. You see, like, all we did really is swap the places of these and then negate that. That's all we did, okay? Now, let's find the GCF. What do these have in common? Well, they definitely have the 4u minus v in common by construction. We did that intentionally. But what else do they have in common? What can we also factor out? Well, between 18 and 30, maybe just a 2, 3 maybe. That's pretty cool. Didn't think about 3. So 3, 6, maybe 6. Oh, I'm a dummy. Yeah, 6. Let's pull out a 6. So we got 6. If we pull out between u and u squared, we can pull out a u. Between v squared and v, we can pull out a v. So this whole thing is our GCF. Does that make sense? We pulled these terms out of that term and that term. Now we still have to write what's left. 18 over 6 is 3. U over U is 1. V squared over V is V. 4U minus V over 4U minus V cancels out, it's just 1. So just 3V from the first term. Now second term. 30 over 6 is 5. U squared over U is U. V over V is 1. 4U minus V over 4U minus V is 1. So this is pretty much it. I'm curious if they've written it differently. Let's see how I have it written here. No, it's pretty spot on. Okay, yeah. That's all there is to it. Hope that made sense. Let's go to number 5. Factor the polynomial. Okay. So what I'm going to suggest here is factor this first as if it's 3u squared plus 10u minus 8. Factor it as if the v's are not there. Okay? And so what we're going to do then is think about what 3 times 8 is. And so we're going to do this method of sliding and dividing. So we're going to do minus 24, and then we're going to ask ourselves what multiplies to 24 but adds to 10. So we're going to do, what can we do? We can do u plus 12 and u minus 2. 12 times negative 2 is negative 24, and 12 minus 2 is 10. We need to make sure we divide back out by that 3. And so if we multiply by 3 at the start, we divide back out by the 3. And so then what we get is u plus 4. So if it divides nicely, go ahead and divide it nicely. If it does not divide nicely, go ahead and rewrite it as 3u minus 2. So throw that 3 in front of the u. So this would produce this. But now if we just introduce the v's back in, we're going to multiply v's on the end here. The reason we multiply it just on the ends is because if we think about it, 4v times negative 2v is negative 8v squared. If we did the whole middle term stuff, we would end up getting, u times, 4v times 3u, that's 12uv, and then u times negative 2v is minus 2uv, so 12uv minus 2uv is 10uv. Anyway, it works out. That's sliding and dividing. I do want to explore like one other option because I'm kind of getting the gist that they might want to not have you do, like they want you to do something similar to slide and divide, but I'm going to explore this real quick. Imagine we just kind of pictured 3 times 8 here and got 24 and still just like broke it up. Basically like thought about how still plus 12 and minus 2 give us the 10 in the middle. Like think about 3 times 8 is the negative 24. The negative 8 is negative 24. And then what multiplies to negative 24 but adds to 10, you would do like plus 12 uv minus 2 uv, and then just keep the minus 8v there. So you sort of like envision that 24. For me, it's easier to like do it like this, and it's hard to like picture it this way, but just to kind of give you a little bit of insight, maybe you prefer this way. If you can visualize this and come up with this, then it's just a greatest common factor exercise, because then you can take the approach of greatest common factor for the first 2 terms. It's like factoring by grouping. So first 2 terms, you'd get 3u factored out, leaving you with u plus v. Second 2 terms, you can factor out a greatest common factor of minus 2v, leaving you with a u plus, is that 4? Oh, sorry, I missed a 4v on the first part. That was my bad. It's a train wreck. But basically, if you factor out 3u on the first one, you would have got u plus 4v minus 2v on the second one, you get u plus 4v. So then you do the GCF for this and that, like we kind of were doing before, and get u plus 4v times 3u minus 2v. Like these end up making that factor. Anyway, so that's kind of another approach to it. Similar but different. Whichever you prefer, use that. All right, number 6. Factor the polynomial. Okay. Whenever you see an expression of the form a squared minus b squared. This is what's known as a difference of two squares, and we can factor it into a minus b times a plus b. So in this case, 100x squared is our a squared, which means the square root of that is our a. The square root of that is 10x. B squared is 4y squared, so the square root of that is 2y. So we have 10x minus 2y and 10x plus 2y. Now, I'm almost second guessing this. I wonder if they want us to keep it like that, or if they want us to factor out a 4 first. Okay, I don't know. If we factored out a 4 first and said, GCF is important, you always want to do that first, we would have gotten 25x squared minus y squared, and then you would have done the difference of two squares there. So you would have gotten 4 times 5x minus y and 5x plus y. So the question is, which one of these is our answer? I'm leaning towards this one because typically you want to do GCF first, but let's see what the answer is here. Yeah, okay, so they did do the 4. So be cautious of that. Lesson learned here is always look for a GCF first, then factor. Regardless, it's, these are still correct factors, but this is probably the preferred factored form. All right, number 7, factor the polynomial. So now in this case, notice we cannot pull out a GCF, but it is still a difference of two squares. 9 is a perfect square, 25 is a perfect square, a squared, b squared, c squared, all perfect squares. So square root of this is 3ab. Square root of this is 5c. So we have 3ab minus 5c, 3ab plus 5c. That's all there is to it. Number 8, factor the polynomial. Let's see if we can try that previous method. So 4 times 9 is 36. So just to get a visual, 36 is what we're multiplying to. So we'll call it a times b. But negative 12 is what a plus b should equal. Okay? So what multiplies to 36 but adds to negative 12? 6 and 6. Yeah, that's probably right. So negative 6, negative 6. Yeah, okay. So let's write the polynomial like this. 4u squared minus 6uv minus 6uv. So you're breaking that 12, that minus 12, into the a and the b. So negative 6, and then plus 9b squared. So we're testing this out here mid-video. So again, what we do is GCF of these two terms. So that's going to be 2u. Factoring out 2u there would give us a 2u minus 3v. Doing a GCF for the second pair here, we have minus 3. Minus 3v. So if we pull out a minus 3v from this first term, or just 3v from 6uv, we get 2u. And then 3v taken away from 9v squared is 3v. Okay? And then, am I missing something here? Yes, I am. Sorry, we have to consider we're taking out a negative 3v from a positive. So it's like 9v squared divided by negative 3v. So it gives us that negative 3v. So the reason I was able to catch that is because we want these two to match. Okay? So that we look at these two terms now right here, and we ask ourselves, what's the GCF? Well, the GCF is the one big factor they have in common, which is 2u minus 3v. So that leaves us with 2u minus 3v there. So what a coincidence. They're the same exact terms. So that was just a little test. If you like that method, use that method. If you don't like that method, treat it like we did before. 4u squared minus 12uv. Multiply the 4 to the end here. So you get plus 36v squared. Maybe take out the v's, factor it like normal. You'd end up getting u minus 6, u minus 6. Make sure to divide back out by the 4. If you divide back out by the 4, you're going to get 3 over 2. So then if you get 3 over 2, you move that 2 to the front. So it's 2u minus 3, 2u minus 3 for both of them. And then you introduce the v's back in the mix. So you tack on the v's there, v's there. Maybe that one's easier. It don't matter. That was number 8. Factor the polynomial once again. Let's go GCF route. Very big GCFs here. We got 2 in common. We got m in common. And that's it. What does that leave us with? We take out the 2 from the 2. We get 1. M from the m cubed. We get m squared. 2m from 2m squared is m. 2m from minus 60m is minus 30. Okay, then we can factor that a little bit further. Multiplying to negative 30, but adding to 1. m plus 6 minus 5. 6 times negative 5 is negative 30. 6 minus 5 is a 1. Number 10, factor the polynomial. Once again, GCF first. So what do these have in common? Maybe a 2. Let's go 2. They all have a y. They don't all have an x, so we have to just leave it like that. Factoring out 2y from the first one, 20 divided by 2 is 10. X squared, y over y goes away. Minus 34 over 2 is minus 17. X stays, but y over y goes away. So then minus 40 over 2 is minus 20, and then y over y goes away. Okay, so can we factor this? Good night. That's crazy. I think it is factorable. Oh my gosh. Okay. So let's demonstrate slide and divide. Might also try to demonstrate the other method. Sliding and dividing. We're going to multiply the 10 over here. We get x squared minus 17x minus 200. And I think you can find two numbers that multiply to 200, negative 200, but that add to negative 17. I'm thinking a minus 25 and a plus 8. Think quarters. If you have 8 quarters, you got $2. You know what I'm saying? So then you would divide both those by 10, basically. And you'd get 5 over 2 once you simplify. And then 4 over 5 once you simplify. And then you'd move those to the front. So it'd be 2x minus 5 and 5x plus 4. So I think those would be your answers. Let's see if I can back it up and show you where you could have done the other method. So right around where? Right around when we did the whole 200 thing. So this is an alternate route you could have taken. You could have rewritten this term as minus, here we go. You would have thought about 10 times negative 20 is negative 200, and then minus 25x and plus 8x is negative 17x. So you're replacing the negative 17x with these, and then minus 20. Then you go the GCF route, and you factor out a GCF here and here. So you'd get 5x, which will leave you with 2x minus 5, and then plus 4, which is x minus 5, and then, whoops, no, sorry, 4, I did it too fast. Factor out of 4, which is 2x minus 5. Again, we want these to match, so we can then factor that out. Factoring out GCF from here and here, we get 2x minus 5 times 5x plus 4. Quite the mamma jamma, but we get there either way. All right, I'm done doing 2 methods for each problem. Let's keep going. Factor the polynomial. So greatest common factor is maybe u squared v. They both have a u squared and v in common. That leaves us with a 4u squared and minus 9 u squared over u squared is gone. V cubed over v is v squared. And then what we have here is a difference of two squares. So we break it into the plus and minus situation. So square root of that is 2u minus square root of that, 3v. And then we do minus and we do plus. So 2u minus 3v, 2u plus 3v. Number 12, factor this polynomial. It's important to recognize this and this is a sum of two cubes. It might be helpful to know this formula for factoring a sum of two cubes. If it's a plus b, or a squared plus b, a cubed plus b cubed, you have a plus b, a squared minus ab plus b squared. If it was a difference of two cubes, which we might also see, so maybe I don't need to do it now, but you'd get a minus b, a squared plus ab plus b squared. So they're very similar, but you might see the differences there. So using the first one, a cubed is 8m cubed, which means a is just the cube root of 8m cubed, so just 2m. B cubed is 1, which means the cube root of 1 is our b, so just positive 1. So this is our a plus b portion here. Now we need the rest. We need an a squared minus ab plus b squared. So again, a is 2m. So am squared is 2m squared. 2m squared is 4m squared, because 2 times 2, m times m. A times b is 2m times 1, so minus 2m. B squared is 1 times 1, or 1 squared, so just 1. And that's it. We typically can't factor the second part whenever we do a sum or difference of two cubes. Number 13. Oh, look at that. Difference of two cubes. A cubed minus b cubed, again, equals a minus b times a squared plus ab plus b squared. In this case, a would be the cube root of that, so that would be 3m. Cube root of 8 is 2, so 3m minus 2 to start. And then, let's go ahead and get rid of that. And then a squared would be 3m squared, so 3m times 3m is 9m squared. Plus ab, that's 3m times 2, so that's 6m. Plus b squared, well, b is just 2, so 2 times 2 is 4, and that's all there is to it. 14, sum of two cubes. A cubed is x cubed, so a is just x. B cubed is 64y cubed, which means b is just the cube root of 64, so 4, and cube root of y cubed, y. So that's our a plus b. Our, again, a is x and b is 4y, so a squared is x squared. Minus ab would be minus 4xy, plus b squared would be 16y squared. Last but not least, number 15. Factor the polynomial. So maybe GCF first? No GCF. Interesting. Okay. Yeah, that's fun. Okay. So you want to treat it. What's the best way to describe this one? I mean, if it helps, kind of just think about it as if it were like x squared minus x minus 30. That's kind of going to be it. And then you just think about, like, how do you factor this? Well, you're going to have x minus 6 and x plus 5. Because negative 6 times 5 is negative 30. Negative 6 plus 5 is negative 1. And then you kind of just, like, start making replacements here. You ready? So instead of x squared, what we really have is u squared squared. So, because u squared squared is x to the 4th. So in everywhere we have x, we actually want to write u squared. Because in place of this x, we also have u squared. And then this is where we introduce the v's back. Well, 6 what times 5 what would give us 30v to the fourth. Well, that means we need to tack on v squared to both of these. And then that naturally would introduce the v to the fourth here and the v squared in the middle. Now, in terms of like how they wanted you to do that, I have no freaking clue. Maybe the route of like figuring out negative 30 is the negative 6 and the 5. So it's like you would have broken up this right here into negative 6 u squared v squared plus 5 u squared v squared, and then minus 30v to the fourth. So it's like if you can make that jump from here to here, then it's just a GCF thing because you're factoring by grouping. So first pair here, GCF would be u squared. That would leave us with a u squared minus 6v squared. GCF here would be plus 5v squared. And so factoring that out would leave us with a u squared minus 6v squared again. Then GCF amongst these would be that, factor that's identical. So u squared minus 6v squared, and then what's left is the u squared plus 5v squared. So whichever method gets you there, whichever you prefer, I think should be fine. All right, I believe that was it. That was web assignment number 1.3 on factoring. If you have any questions, please let me know. As they say, bye.